All right, we're going to look at how to use row reduction in order to use a matrix to solve a system. So an echelon form just means it has the following properties. All non-zero rows are above any rows of all zeros. So if you have all zeros, they're all at the bottom. Each leading entry of the row is in a column to the right of the leading entry of the row above it. And you're like, what? Okay. Each leading entry of a row is in a column. So leading entry meaning like there's a 0 and then there's a 1, is in a column to the right of the leading entry of the row above it. That's what it means. So if I have a leading term here, it is to the right of the leading term in the row above it. Okay. All entries in a column below a leading entry are zeros. So if I have a 1 here, these are all zeros. If I have a leading 1 here, this has to be a 0, and then this has to be a 1. Okay. Now these can be any number. To be to be just in row echelon form. Now we're in reduced row echelon form if it's also true that the leading entry in each row is 1, so that's that first one, and the leading one is the only non-zero entry in its entire column. So this is actually all zeros here, and then we have number, number, number. Okay, that's reduced row echelon form. So let's look at how to do that here. Apply elementary row operations to put this into echelon form and then into reduced row echelon form. So begin with the leftmost non-zero column. We call that the pivot column. Bam, bam. Okay, now we need that to be pivoted to the top. So we're going to change this so that I have 1, 1, 2, 0. And we're just going to exchange rows 1 and 3 so that it moves to the top. Okay. Select a non-zero entry in the pivot column as the pivot. Interchange rows as necessary. That's what we did right here. Okay. Use row replacement operation to create zeros in all positions below the pivot. Done. Okay, so we are done. This is our pivot right here. We have all zeros below it. Amazing. Cover or ignore the row containing the pivot position and cover all the rows, if any, above it. Apply steps 1 through 3 to the submatrix that remains. So now if I'm looking at just this piece right here, I want to do that same thing. So pivot column, but I need that to be up at the top. So I need to move these two and replace them with each other. Sorry, give me just a second here. I covered up my little toolbar. Okay, so this one is good. I then have 0, 1, 7, 0, 0, 0, 2, -2. Now, beginning with the rightmost pivot and working upward, create zeros above each pivot. If a pivot is not 1, make it by a scaling operation. All right, so rightmost pivot is right here. Working upward and left, create zeros above each one. Well, the first thing to do is I need to make this a 1. So I'm going to do that by just multiplying by a half here. Okay, so I'm going to say take -7 times row 3 and add that to row 2, -7 times 1, add that to 7. That's going to zero that out and put that back into row 2. So when I do that, too much. Beautiful. Okay, so when I do that, 1 and 3 stay the same. I'm changing row 2. So 0 plus 0, 0. 0 plus 1, 1. -7 plus 7, 0. -7, here's 7, plus 0, 7. Amazing, 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 amazing. Okay, now I need to do that again to get into row 1. So I need to take -2, row 3, and add that to row 1. Put that back into row 1. Okay, -2, row 3, -2 times 0, 0 plus 1, 1, 0 plus 1, 1. Here I have -1, or 2, excuse me, -2 times 1, -2 plus 2, 0. -1 times -2, so 2 plus 0, 2. And then I also need to do that for this because everything that has a 1, I need zeros all the way above it to get into reduced row echelon form. So row 2 minus row 1, put that back into row 1. Oh, that's a 1. 1. Okay, so if I take 0, I'm going to switch this actually. Negative row 2 plus row 1. Otherwise, I'm going to make it yucky on that first one, right? Okay, so 0, -0 plus 1, 1. Done. -1 plus 1, 0. Done. 0 plus 0, 0. Okay, -7 plus 2, -5. Now, what does that do? That means I now have my solution matrix here. Okay, I have my solution vector is really what it's going to be. X1 has to be -5, X2 has to be 7, and X3 has to be -1. So if you can get it into that reduced row echelon form, there's no need to plug back into the system and back solve with substitution because you will be able to find the solution. It is just your answers in that right-hand side.